Alright, in this video I'm going to look at three more examples of using integration by substitution, or for short we're looking at using our U substitution here. So I may give you a second here to see if you can integrate this problem. Maybe you want to pause the video and see if you can find the integral of x times x plus 9 dx and see if you can come up with the correct answer. Alright, hopefully you took the time to pause that to see what you'd come up with. For example, if you tried to let u equal this x plus 9, thinking this is the inside function here, if we let u equal x plus 9, then du would be equal to the derivative of x, which would just be 1 dx. And we look over here and say, well, we have, if this is our u, x plus 9, then we have dx for the du. We have a 1 because we can think of this as 1 dx, but we have this extra x here and we can't get rid of that. So the u substitution here is not going to work with this example because we need to have exactly u and then our du, but du is simply dx, but we have this extra variable x. So this is not going to work. And you may think, if you look closely back at this example, did we really need to use u substitution? Well, if you notice, this is really not a composite function. We have x multiplied by x plus 9. The examples we looked at before had x plus 9 raised to a power such as to the 4th or to the 5th or 6th, or maybe we're taking the square root of it, so we had our composite function and the u substitution worked nicely. But for this problem, we don't need u substitution. So be very careful. Sometimes you'll come across a problem and you'll try to force this u substitution, but we could certainly just rewrite this problem by using the distributive property. We can distribute the x and we would get x squared plus 9x, and it just becomes a very basic integration problem, and we would get x cubed over 3 plus 9x squared divided by 2 plus c. Alright, so there's your answer. X cubed plus 9x squared over 2 plus c, and there's our integral. And again, that was simply by distributing. Now be careful, that doesn't work if this x plus 9 is raised to a power. So be careful. Every now and then I might sneak in a problem there, and you may think you're trying to use u substitution, but it is not required for the example. All right, here we have an example of a trig function. We have the integral of sine of 4x dx. Now this one's a little bit different. What do you think we're going to let u equal? Well, if you think of your sine function is the outside function, the 4x is on the inside. And again, if you get confused about what's on the inside or outside, just ask yourself, if you were actually calculating this problem, if you were trying to take the sine of this 4x, pretend that we had a value for x, and once you multiply that by the 4, what is the first step you would do? Well, the first step is you would multiply the value of x by 4, and the last thing you would do is take the sine of it. So therefore, the inside part is the 4x. So it looks like we would probably let u equal 4x. And if we let u equal 4x, then the derivative of u would be 4 dx. Now, keep in mind, what was the integral of your sine function? Let's maybe look at that before we go any further. If you look at your formula, the integral of sine is the integral of sine of u du, correct? So if we have the integral of sine of u du for your formula, and it says that's equal to the negative cosine of u plus c, if this is our formula for the integral of the sine, notice it says we want the sine of u du. Well, that's why we let u equal the inside, the 4x, and then we took the derivative of u, so the derivative of 4x became 4 dx, and once again we have the dx, but we're missing the 4, so we need to multiply in here by 4 so that we have this 4 dx as our du, but that means we'd have to multiply by 1/4 out front. So we would have 1/4 the integral of sine of 4x. Okay, so that's the sine of u, and we would have our 4 dx, and 4 dx would be our du. So again, that means the 4 dx is going to eventually just disappear. So if we rewrite this, we would simply have 1/4 the integral of the sine of u du. And over here, we know the integral of the sine of u du is the negative cosine of u. So we bring down the 1/4. So that's 1/4 times the negative cosine of u plus c. So we can actually simplify this. 1/4 times the negative, so that would just be a negative 1/4 cosine of u plus c. And your final step, we want to substitute back in. We have negative 1/4 cosine of u. Well, our u, if you recall, is the 4x. So that would be negative 1/4 cosine of 4x plus c. So not always, but typically if you have a trig function, and based on the formula, the integral of sine of u du, again, your u is the inside part of the function, and our u then would be the sine of 4x, so the u is 4x, and then the derivative would be 4 dx. So keep that in mind when you're working with a trig function. Probably most of the time you're going to let the u equal that inside part of your trig function. Now, as I state that, we come down to our next example here, which involves two trig functions, cosine of x over the sine cubed of x. Now, with having two functions here, notice you might think, well, we could let u equal the inside function. Well, the inside function would just simply be the x. And if we let u equal x, then du is just going to be 1 dx. And that's not really going to help us out here with this example. So if you look closely, what else do you think we could try to let u equal so that we take the derivative of u, we would have that du over here in the original problem? Well, you may think we have sine cubed, so you could think of that as your inside function. In other words, if I was to rewrite this, couldn't we think of this as cosine x over, remember this sine cubed is the same thing as writing sine of x cubed. So if I write it this way, you can clearly see that this inside function might be our sine of x. So if I let u equal sine of x, this inside part here, then du, the derivative of sine, is cosine x dx. And if we look up here, we do have what? Cosine x dx would be our du. So if we rewrite this, I could bring sine x to the top, and if I did that, I'm going to write it as sine x to the negative 3 cosine x dx. And again, I'll group all this du together so we can easily identify that. All right, so now we have the integral of what? U to the negative 3 du. So that becomes u to the negative 2 divided by negative 2 plus c. And once again, our last step would be to substitute back in. Our u is sine of x. So in this case, we would end up with sine of x raised to the negative second power divided by negative 2 plus c. Now, if you notice, I left the exponent as a negative here. So you may see the answer this way. An alternate way is we could write this as negative 1 over 2 multiplied by sine of x squared. Okay, now keep in mind as well with this squared, we could write it as negative 1 over 2 sine squared x, and of course plus c for both of these. We'd still have our plus constant here. But notice you can write this sine of x in parentheses with the square on the outside, or the shorthand, we could write this as 2 sine squared x. Both of those would be the same, and either one would be acceptable. Now, another alternate answer that you could possibly see is if you were to write this then as negative 1/2. Now what about sine squared x? That's 1 over sine squared. Well, if we have 1 over sine squared x, isn't that equal to what reciprocal? Wouldn't that be the same thing as cosecant squared x? So it's possible you could even see the answer written as negative 1/2 cosecant squared x plus c, because remember 1 over sine is equal to cosecant. So any of these would be acceptable answers, and sometimes you'll notice that the further you go here in calculus, a lot of times they don't get too obsessed with making your exponents positive, and they'll just leave them as a negative. But for me, I would accept either way. And really, well, you have 1, 2, 3, 4 different answers, and really all 4 of these would be acceptable answers. So keep in mind here, when a lot of cases with your trig functions, you're going to let the u equal, like we did in the first example, this inside part, the 4x. But if you have other trig functions involved, such as this one, it's a good chance that we may let u equal the entire trig function. And in some other cases, you may have the opportunity to use your trig identities to rewrite this into another form before doing the u substitution. So keep in mind, you have to always remember all of the techniques we talked about previously, as in this first example, is just straightforward distribute and integrate. There was no u substitution involved. So as you go through, please don't forget all of the rules that you've learned up to this point.